Hi, everybody. How are you? Welcome, welcome, welcome. I hope you are fine. We have a beautiful day here in Prague. Hi, Internet. How are you? Hope you are also fine and they're watching us. So today we are going to have our second class of Introduction to Security. I hope you are comfortable and you have with you your food and water and all your energy to keep focus. It's going to be a very nice, intense class. Today we have finding computers, scanning, and basic network analysis, with also the beautiful image done by Fermín Valeros for us, exclusive of this document. So October the 2nd, the one where we are like Trinity and we use Nmap. If you don't know who Trinity is, I mean, just, I don't want to know, just go or something. These are the credits of the class, and we are gonna have the same links as before. I'm gonna skim over these ones. This is a moment for you to install Wireshark. It's a tool for looking at packets in your computer, not your Dockers. So right now, you can go there, click, and take, while I'm introducing, 2-3 minutes to install Wireshark in your computer. It's very simple, very small. You can have it later because we are going to be using it all over the class. Internet, also for you, okay? At home, wherever you are, get comfortable and install Wireshark while I'm talking. Any problem, Internet, and also here, you can chat us. We are in Matrix right now here for you. So go there, say hi, and contact with the rest of the people of the world. There are people right now taking this class in the middle of the night, in the morning, in many, many different weather conditions. So you can go and say, hi, people, how are you? So we have surprise Pioneer prizes. If you remember last class at 9, right? 9, we opened the assignment number 1 that was simple. It was to get you warm up. So whoever solved those fastest has Pioneer prizes. So the third place, it's a TCP packet programmable electronic badge. There you go. Maurice can show it. It's very, very nice. And you can see the company who did it and the information there. And we know the winners because if you remember, you are putting the flags in CTFD. And then every moment you present and you send the flag, the exact time is recorded. And it was very, very tight. I think the second and third place were separated by less than a second. I don't know, half a second or something. And the first one was separated by 3 seconds. So every second counts here. And the third place goes to, I don't have a thing to him, to Yagosmar. Yagosmar, are you here? Yagosmar, oh, he or she is not here. Oh my God, what are we doing? I think it's vacant, right? It's vacant. So Yagosmar, if you are around, you have, I think not. I will give 3 hours for this to pick up, and then we can talk. I'm not sure. So the second place is a Sidwin Xiao SAM21, beautiful microprocessor programmable. You can control IoT stuff around. And the second place goes to Zahorto 2. Zahorto 2, are you here? There you go. Bravo. See, somebody that is here picking up the prizes. Well done, Zahorto. Enjoy it. And the first place, with 2 seconds to spare, goes to Kupkayan. There you go. Bravo, Kupkayan. Well done, people. There you go. A beautiful Raspberry Pi Pico with Wi-Fi, version 2, the last one. This is a good thing. So there you go. You enjoy. You can port scan from there if you want to. So remember that even today, almost every class, at 9, we are going to be opening the assignment. Go participate. You never know how hard or difficult or easy it is. The first 3 may have some Pioneer prizes, okay? Then we have a survey last class. Remember, every class, we really, really want what you think about the class. Internet, and here, everybody, go to the feedback and tell us how it went. So the last class, we have a lot of people saying that it was the speed of the class okay. For some people, it was slow, and for 30% was too much. So today, we are going to be slowing down a little bit, okay? And then we are going to be adjusting. Then we have how you were able to follow along and run the commands during the class. There are some people that were not so much, so I hope that you're asking more questions and also asking more in Element if you cannot follow along. Were you able to follow what the teacher explained during the class? 5, 4, 9, and then 4, 2, and 3. Let's try this class to be more clear so you can tell me if you cannot understand. Maybe it's related to the speed, so maybe being a little bit slower will help. How useful was the class document and other supporting resources? It was helpful for the majority, so we are going to keep taking feedback, okay? Now, parish notices. We have 2 parish notices. The first one is that, if you remember, at the end of the year, we're going to have the bonus assignment. The bonus assignment, if you do correctly and you approve, you don't go to the final exam. However, we hint last class that to unlock the possibility of the bonus assignment, there's going to be a report. So the rules are you need to send us 1 report for 1 assignment, and this assignment should be one of those that we are doing the semester. In particular, the assignments from 2 to 5. So we already have 1. We are going to have 4 more. You pick one of those, and then you do a report of how you solve it, okay? We are going to be opening a CTFD challenge for this, so during this time, you can go pick one of these 5, so you have time, there is no rush in this one, and then you see how you do the report, you create your report, you send to the CTFD. If you do that correctly, the bonus will unlock, and in December, you can have the bonus. Here is an example report for you done by Moody's. So please go, download, check, and you have instructions how to do a report, why to do a report, how to put commands, how to put screenshots, and everything. This is important because for the bonus and for the exam, you approve with a report. Yes, during the exam, you need to send a report. So you need to know how to do that, right? If you don't do that correctly, it's going to be a little bit slower, okay? And the deadline to submit the unlock report is December 11. Okay, everybody? So put it in your calendars. Questions about this one? Perfect. So the mock password, some people were saying that was some misspelling and were trying to correct the mistake. No, it may be misspelled on purpose, okay? So you have to put it exactly as you see in the screen, okay? Internet, if you see that you believe it's an error, it doesn't matter, it's not an error, you need to put exactly what you see there. We saw some people trying to fix the error. It's to know if you are aware and attentive to the password, okay, Internet? If not, you can ask questions. And then we have what I consider the news of the year. We have such a nice surprise. This is Valero's idea. And the last class of this course, in January the 8th, we are going to have the last class with a topic that you can pick. So we are going to be offering topics, and then you say, I vote for this topic, I vote for that topic, and then we present that topic. But how would you be able to vote for this? Internet, how would you be able to vote for this? And the way we are going to be doing voting is by postcards, people. So here, Internet, and you here, if you want to vote for the last topic, you go with a piece of paper, write a postcard, you send us to our direction. You can go here to the link, how to vote, and we have exact the direction, and then you pick the topics. These are the topics, 4 topics, and then you can have a say and vote for the last class of the semester. And you can send a nice postcard and put something nice, and maybe we later can take pictures and put online. So we have even a video of how to mail a postcard if you don't know how to mail a postcard internet. So if you need help, there you go, okay? So we are very eager to see your postcards arriving. Of course, postcards can take some time to arrive from very far away in the world. So you will have until, I think it was, let me go to the deadline. It's December the 5th. That day, whatever we have in the PO box, we take and we count. If it arrives later, we cannot, okay? So start preparing, vote, and send your postcards along the way, okay? Questions about the postcard sending? No questions? And no handling in person here. So even you here, postcards, okay? So that being said, we have the goal for the class to learn how to find computers and services during the reconnaissance phase and how to detect them in the network. That's going to be our topic today. So, getting ready. Today, we are going to be finding new devices in the network, new computers. That means that we need to capture packets. And capture packets means creating a PCAP file. We like to say PCAP file or it didn't happen. If you need to show that something happened, you need to show the evidence. And that is the PCAP file. So here in your Docker containers, please go to your CTU Docker containers, CTU students, and mock students, you go to your traditional SCL lab. I have mine in here. It's a little bit big, but believe me, it's here. So you can go to your Dockers, please, and let's start capturing packets, okay? I will give you some seconds for you to connect and be ready. And be sure you have the up-to-date version, because Martin is pushing changes during the week, okay? Yes, we have, yeah, a little bit later. You can also start the second class, but we have a little bit later. So, now that you are connecting to your Docker, you need to check which is your IP address. How do you check your IP address? We did it last class. The command is IPA. So if you go to your Docker and you check IPA, you are going to check your IP address. Who can tell me what is my IP address there? Anyone? 100, which one? One 172 20 0. What else? 0. And what is the last number? .2, there you go. The P, complete IP, 172.20.02. That's my IP, okay? So you go and check it, Ethernet 0, you should get it there. There you go. You ready? For chocolate? 1, 2, and hutcha. Look at that. Such an, we are getting so good at this. Okay, so if you have your IP address ready, let's start capturing packets on your interface. And that means we are going to be using tcpdump. tcpdump, the de facto standard for capturing and storing packets in the network. We are going to be saying -n, which means do not resolve DNS. We are going to be using -s0, which means put the whole payload of the packets, a little bit old because now you don't need that, and then which interface we are going to be looking packets. So if you do that command, you should see packets in your network. Do you see that, people? Those are your own packets. These are things traveling in the network and reaching your interface. I'm going to press Ctrl-C here. What is that traffic? What I have so much traffic? I'm being attacked. It's my SSH connection, the same connection I'm using to get into this Docker. You will see there because that's your own packets. So be ready to press Ctrl-C and stop the tcpdump, okay? Questions? Perfect. After this, because we are looking at a lot of packets, we can actually filter out packets because we don't want everything. And for that, we can use filters in tcpdump. That means tcpdump -n S0, the interface, and then I'm going to say the port. Which port? Source port or destination port? Well, any port should be different, exclamation mark, 22. So if you do that, then you should have a tcpdump running that should not show that traffic, unless somebody else is connecting and sending packets to you in that same moment. So if you do that, anything that is port 22, you are not going to see, OK? Is it clear? Looking at packets? Oh, there you go. We have 2 ARP packets. So now in your Docker, you are looking at everything going in and out of your interface that is not port 22. After this, you can check that now talking from a security perspective, this filter is not good. Because if you are a security analyst, you want to see packets from other people going to port 22. Because they're going to be trying to log in. They're going to try to brute force to attack. So you don't want to not see all the 22 traffic. So what you do? How do you do not to see your own traffic, but to see the traffic of others? And for that, we're going to be using another filter, that is how to filter off your own IP. The best way to find which IP address you are using to connect to this computer is with the echo command and the global variable SSH connection. So this is a variable that is created every time you connect remotely with SSH, and you have 4 pieces of information. This is the IP you are coming from and the port, and the IP of this computer and the port, OK? This is the easiest way to know when you SSH into a computer, from where are you coming, OK? If you are coming, for example, from, in this case, a computer in the university, that is the IP address of my client, whatever EduROM I'm using now, going to the SSH. Was it clear? No questions? Any questions? Anybody lost? That don't know what we are doing? Where are you? Who are we? No? OK. So after looking at this variable, you can directly try to put your IP address and filter you out. So you can actually do, hey, tcpdump, everything the same, but now the host is not whatever IP address you have there. So you can do that. It's a good idea. You can go here, and then you put here any IP address. That's not an IP address, but you can try. And then that host is not going to be shown. But the problem is that every time you change IP, you go home, EduROM, some coffee shop, the IP is going to change. So an automatic way to always filter out whatever connection you're using is by passing the content of that variable, but processed to extract in columns, only the first columns, directly as a value to tcpdump. So this $& is called a command substitution. And in your terminal, you are going to substitute whatever result is of that operation inside the command. So if you do the tcpdump directly like that, you will see that the SSH connection gave you an IP, and then you use it directly there. Let's cut this out a little bit so you know how it works. If I do echo SSH connection, cut something, and I press enter, it's going to say, hey, the command is not found, because gave me the IP and tried to execute it, but it's an IP address. You cannot execute that. If I remove this execution substitution, then you just have the IP. If you just take out the cat, then you have back all the text, OK? So the cat was separating the columns with spaces, first column, second column, third column, fourth column, and then F1 was taking the first column, OK? That way, you can now filter out everything that is coming from your computer. Alternatively, you can use SS also, like a replacement for if config, and then you can have here a script foo that you can do the same cutting and checking and doing exactly the same magic in another way, OK? So far, we have a tcpdump and that tcpdump is able to see packets and not showing your own packets. By the way, from the perspective of AI, any AI that you are using, it's not going to help you much in sniffing packets. It's kind of a technical thing. At most, it can explain and teach, right? So in a lot of people, you can get packets like these ones, and then you guys just go here, for example, to this AI, and you can ask for an explanation, right? Actually, I have some here. This is too big, but if you believe me, there. You can even put here, press enter in SCL. Remember, you have the AI, and in some minutes, it's going to explain to you what it is. So AI can help you understand, not much than that. Now that we are having this, we are ready to actually store packets in a capture file. So our goal is to leave tcpdump running in your Docker's internet, and capture everything coming and going. And this is something we are going to be using in the class. So please leave it running in your computers. First, before going into that, we are going to say a little bit what is a PCAP. So a PCAP is a format. It's a format like a docx, like any other document, any other file, like X files, like ELF files. And these file formats are prepared to store packets. So it was originally defined in a document, a request for comments document, RFC, and you can go and read, and there you will learn everything you have to learn about this format. If you don't know the RFC documents, these are the standards that define how the internet works. Everything you need to know about how the internet works, from any protocol, TCP, IP, SMTP, POP3, whatever, must have an official document. Any operating system that is implementing any protocol will go there and read. So that is the source piece of information. Now also we have PCAP NG, like kind of the new version. So that's a little bit better, and you can also go and read there. So we are going to be storing inside a PCAP format file. For doing so, we are going to introduce another command that is tmax. Tmax, who knows tmax here? Tmax, oh, there you go, so nice. So tmax, for those on the internet, if you don't know, it's a program that allows you to have like virtual terminals, okay? So we are going to use tmax, and then we are going to create a new virtual terminal called capture. So new name capture. If I go to Strato Cyberlab, and I just do it here, there you go. I have a new terminal called capture. If you want to get out, you need to press Control-B and then D. Control-B and then D. So Control-B and then D. Control-B, you let both keys and press, and then D. And now you have two terminals, see? I'm typing here, and that is some terminal. And then I can go back to tmax, connect, A is attached. I can attach to the virtual terminal called capture, and oh, I don't have it there. Weird, something happened. Huh. Oh, I know what happened. I have too many. So I have to, I create like 3. So if I want to see how many virtual terminals I have, you can do tmax ls. Yeah, I have 3 with the same name. So now I need to choose, and I will attach to the one called 0, capture 0. And that's this one. I will get out. That is all of them because they're the same. And I now can create a new one, okay? So you are in this step. Create a new terminal, enter, and whatever you type here, it's not what you have in this terminal. Is it clear for everybody? 2 terminals, you switch between one and the other. Very handy if you want to have 20 different sessions, but only one terminal in your screen. So you don't need to have 20 SSH simultaneously, okay? Questions here? I will leave some seconds for the internet if you have questions. Yes, yes. You can also have 2 terminals and not use tmax. In the case of SCL, it's going to be hard because you only have 1. Yeah. You can SSH from your own computer, like Mari says. You can have many. But, for example, if you want to have some capture packet or some program in the background running forever, even when you disconnect, it's a nice idea to have Tmax there. No Tmax questions? You sure? No questions so far?
What is the difference with the screen command?
What is the difference between the screen command? I will give you a candy internet, but I don't have a way, so that was for Mari. Well, there is not a lot. Tmax is newer, and it's, in my opinion, more lightweight, with more features, faster. That's my opinion. But honestly, I don't see a lot. If anybody knows a strong difference between screen and Tmax, not a lot. I like it more the way it's splitting inside horizontally and vertically. It's like very handy, and you can move things around. But after that, no, nothing more. Okay? No more questions? Super. Now that we have the Tmax there, we can do a tcpdump -n -s0 -i for the Ethernet -v, which means be a little bit verbose, and then we are going to be using the new parameter -w, which is write, and we are going to be writing in this file. If you pay attention here, you will see that we are using the percentage y and percentage m, percentage d, that is, so automatically tcpdump is replacing those named in the file with the year, the month, the day, the hour, the minute, and the second. That means that any moment in time that you press enter, the file will have exactly the date and hour and second that you press enter, okay? Then we are going to be using -l. -l means do not buffer tcpdump. Please, as soon as you have packets, put them there. Then we are going to be using capital G. And capital G means rotate the PCAP every X number of seconds. In that case, 86,400 is 1 day. So we are telling tcpdump, create the file, put everything there, every 1 day, rotate and create a new PCAP file. That's because you can have very big PCAP files, like gigabytes and gigabytes, and it's extremely hard to analyze. So it's better to rotate them. And then capital W, which means do not create more than X files. So you don't have infinite files. So you can say, hey, put 7, and then they are rotated. You have always the last 7 files, okay? And then we are putting the same filter as before. Please be sure that the host that I'm using, it's not used. So inside, I'm going to create here, I see if I have my Tmax. Yes, I have one, and it's called capture something. And inside the capture, you can do the tcpdump, press enter, and then you should see this. See? Everybody? You have it? Questions? Please be sure you have it. You will need it later. Internet? Also.
We're having a lot of God numbers. I'm getting 0.
Well, I'm not sure, but something is going on in the network, so we can try to see it again. Yeah, it can be ARP packets. So if you do the tcpdump with all the storing and just the filter and not the B, you have an idea what's going on, and can be ARP packets. It depends what the people is doing around, because the Dockers are different, yeah.
I just got a question. So after 1 day, it will be stored into a file.
Do you feel like talking into the die?
Not really.
Okay, there you go, sound. No, it will be stored packet by packet. One packet and go to the file.
And if I connect from another IP address,
it will be there.
It will be there.
Yes.
The current IP address is
Yes. So the question is, when are the packets roughly stored in the file, and which IP address? In that case, it's every packet without buffer goes to the file, and then the SSH connection is the IP of my connection right now. If you use another IP, it will go there. But if you know the second IP, you can go here and put 2 filters. Host not that one, and host not the other. And that's it, right? Another question? Oh, look at that. We have the first night. Here, hitcha.
Thank you. How do you modify this during the run? I mean, if I now disconnect and you said something like leaving it, like letting it run, even for like longer periods of time, how do I like say, okay, I disconnected from the SSH, now I connected from elsewhere. So I want the like to add into the filter from now on, do not filter.
Once you press enter, you cannot modify that one. You need to stop it and create a new one. But it's fine, you don't care, because you have many files, that's okay. You don't have to have the same file for everything.
Okay, thank you.
Welcome. You can, I don't know what to do. Maybe, okay, give it back and then leave it there and then thank you. Oh, there you go, and you have your chocolate. Whoa, look at that. So, after this, all of you should have a file there, okay? And then you can get out. You can also check if the tcpdump is running, just to be sure, so you are not missing everything. So in my SCL it's not running. You see that there is no tcpdump. And if I go to my Docker, you will see as a process tcpdump, okay? Always verify, always be sure, always double check. Even you can see if the files are ready in TMP. That's another one. So, from time to time, please, if you care about this, you can also copy the files to your computer. So if you are on the internet, locally, you can copy the files from the SCL to your own computer. And if you are in the CTU Dockers, you can do the same with this command. Just as a precaution. Sometimes you are doing an assignment and you have packets and you don't want to, lose anything. And also, we took measures to not fill the disk, but there is a lot of traffic, and you may fill the disk. So please copy those there, okay? Now, yes, that is the issue. Now, for storing packets in a PCAP, actually, AI can help a little bit. There is a company that they create something called the Smart PCAP, and you can read there. And it's not exactly AI, it's a heuristic, but they were very smart in actually allowed you to capture PCAP packets only in certain situations when you have kind of an alert, an anomaly, something to look at in the network. So that company said, well, you cannot store all those packets forever. It's a lot of information. It's too much. But you can have a selective capturing. So I can see an application for some AI taking a decision of, OK, when should I capture these packets? When does it make sense? OK? So let's go to reconnaissance, which is the first step. And for that, we are going to be using Nmap. If you remember, back to our methodology, pen testing methodology, we're going to be attacking. The first thing you should do when you are in a pen testing, apart from signing a contract and having authorizations and stuff like that, is to find what you need to attack. And that step, the reconnaissance step, is the first one. So this means you need to go out and find information about the company, the organization, the domains, which IP addresses, the services, the versions, the people working, the LinkedIn, the TikTok, the Instagram, whatever you can have your hands on. The more information you have, the better. This is related to something called like surface scanning, where you go and see what is the attacking surface. And some companies can be huge, okay? So sometimes just going there and finding 10,000 domains, it's not easy, okay? In our case, it's going to be smaller, but you need to do this according to finding what you need to attack. So in this class, we are going to be focusing on network reconnaissance, not getting out of here, specifically IP ports and services. So we are not going to be doing the OSINT type, which is internet finding about the company, okay? So there are two types of network scanning. In this case, passive and active. When we say passive, we mean that you need to find information about what's going on in the network without sending any packet. So how would you do that? Who can tell us? I have few Mandos. I only have 2 Mandos left. If you saw the Mandalorian series, this is Mando. And I have only 2. So this one goes for who can tell me what does it mean? Where do I get information in the case of the passive reconnaissance? So, if you're not sending packets, yeah, there you go. Hello.
When you're just listening what's happening on the network, you will usually hear other computers just asking for with ARP packets and such.
There you go. So you are sniffing in the network, right, like you're doing right now. Those ARP you saw and say, oh, look, there is a computer talking to me. That's one computer. There is another answering. That's another computer. There is a device. There is a Wi-Fi. You start searching around. Which other way? So we have an issue with this one. Yeah, I think it broke because it's like empty. I'm going to leave the Mando here.
We have from the internet.
Yes.
Honeypot.
Sorry. I didn't say your answer aloud, but it was what I rephrased, right? Like going and checking in the network the packets. Thank you very much, Max.
We have another answer. Honeypots.
Honeypots. Oof. I will go with no internet. Like usually honeypots kind of answer back. If you connect to honeypot, I need to tell you something. So that goes into the active category. Honeypots we are going to see later, but it's mechanisms that you use some deception technique to put a fake service or device in the network. Maybe we can go internet to network telescopes. Network telescopes are a little bit there. Yeah, you receive stuff, but you're not sending back. So that would go there. Another other technique, get into the role of the attacker, people. You're an attacker. You're in a computer. You don't want to send packets. You don't want to ping. How do you find this information? Get into the role. How do you find information of which other computers are around if you cannot send packets? Imagine. You listen to whom? To the network. Broadcast, IRPs, packets, multicast, you sniff in the network. Something more? What about checking the same computer? You're in a computer, probably not your computer. So you can go to the memory of the computer. You can check configuration files. You can check where other programs are trying to go. You can check how is the MySQL database configured. So there is a lot you can learn not sending packets, okay? Very, very important technique in what is called the APT attacks, Advanced Persistent Threat Attacks, usually done by governments. Then we have the active one. In here, you send packets. We are going to be using both. In this one, I send you a packet, and then I receive something back and say, oh, that computer is up, okay? So we are going to be using Nmap. Nmap, if you don't know, it's the de facto tool for scanning port services and finding information, probably one of the most well-known tools since the 90s. I have no idea, 95, 96, still alive and still full of new features. So how do you know that the computer is up? Question for you. And I have a ring, a DEFCON ring for you. How do you know that a computer is up in this active sense? Give you a response. For example, you have something in mind?
Like if I send, for example, like SYN packet, then I get a SYN app, for example.
And then you know. So I get a response, if I send a SYN and I get a SYNAC, that's it. Maybe your packet was not meant to see if the computer was up. Maybe you are actually trying to open a port or to connect to an open port. It doesn't matter. Whatever gets back to you, it's information. There you go. 1, 2, 3. Watch to your finger directly. Wow. You didn't see that, but it was amazing internet. So anything you receive is going to be working for this. And let's use Nmap to actually find these computers up. So now for online students, everyone using the Strato CyberLab, please start the second class. If you go here and you find the second class, you will have, I can make this a little bit smaller. You will have here a button for starting. So you need to start your second class in order to do the rest, okay? If you are using here the CTU Dockers, you are fine, you have everything started already. So, what are we going to be doing? We are going to first use Nmap to find information that is kind of passively, information that is being sent to us without sending packet. And for that, we are going to be using -n, -v, that is do not resolve DNS, then v versus level 1, And we are going to be invoking a script. We are going to be talking scripts a little bit later. We are going to be invoking a script. It's a Lua script. And the script we are going to be invoking is discovery, which means it's going to go here, get the script discovery, and inside there is a code, and it's going to be executing it, right? If you are curious about what Nmap is doing, you can use -d for the bug, and then you will see. So please, go the command, go to wherever you are, and press Enter, and here we have starting Nmap 792 SVM, loaded 309 scripts, pre-scanning, and NSA, that is the Nmap scripting engine, and then has some targets that need to be executed for IPv6. We don't have that here. We don't have an API for Shodan, so it's not going to go to Shodan, which is an online services to search ports on the internet. And it's going to be using here a source IP must be provided. Oh, there you go. So I'm going to go up, and it's going to say, hey, the output of the broadcast script found all these computers. Look at that. Do you have also in the CTU? And also you should have in SCL, not the same IPs, of course, right? Did it work? Not? Yes? That is your computer listening to everything and at the end giving you a complete list of other computers speaking in your network, okay? And then we have, yes, the rob text temporarily disabled, other things around, and at the end then how much time it took and everything, okay? Apart from this, which is passive, we can jump into the ARP technique, which is active. Now we are going to be doing Nmap. Hey, Nmap, yes. Yes, probably like this one. So that means that because by default we are not having Shodan API, it's not going to go to Shodan that is online service to ask about your IP. Shodan is like a service that is scanning the internet and then it's saying you have this open port. If you have a Shodan API key that you can get for free, if you go to shodan.com, then you put it here and then you will go to the internet and ask what the world knows about you, which is not a bad idea actually. Questions, internet? No? More questions here? We also have milk fudges, I don't know. For questions, you can choose. No? Okay, so what is the ARP technique? Do you remember ARP last class? We are talking that there are many ARP requests and replies, many ways of actually exchanging information. If you remember the answer before, any packet going to you, it's an indication that the computer is up. I don't care why. If I see you sending a packet, that means you are power on, and that's it. So this technique of ARP consists exactly in using the ARP protocol to say, do you know the MAC of the computer 172.20.1, 192.20.2, 192.0.3? It's like one by one doing all the IPs and finding what they are doing. By far, this is the best way to find computers in local networks. This only works in local networks. It does not work on the internet networks. Can anybody tell me why ARP techniques are not working on the internet networks? Because it uses multicast. I was going to give you the thing. Actually, not. But it was actually close, because it can be broadcast in the Ethernet level, so everyone will reach it. Even if it's using multicast, that's not the reason why it's going not to work on the internet. Wait, ready? 1, 2, 3. Ocho. So, who can tell us? Too many IPs, where? On the internet. There are a lot of IPs on the internet, but that's not the reason why ARP is not working. Who else? Oh, Max, that's going to be hard. Go. Everything that is outside your local subnetwork is terminated by the gateway. You have a window behind you, so you have to be good at this one. almost. It was very, very fast. That is correct. Like, remember, ARP is a local network protocol because the moment the ARP reaches the router, except situations that are bridging, will not pass the ARP packet to the next network. Two networks do not share what is called the collision domain. ARP, finding computers in the local network, finding if you have the same IP or not, makes sense only in the same network. When you go to another network, other IP addresses, other computers, you don't care. You can have the two same IPs in both networks and it's fine. So two networks do not share the Ethernet level, do not share the collision domain. ARP never gets out, which means it will never reach the internet. There is no Ethernet in the networks between you and wherever Google is. Ethernet is a local protocol. So then you go to ADSL or satellite networks, no ARP there. So there is no way to do this on internet computers. That being said, let's try. So for that, we are going to be doing nmap -sn, small sn. That means disable the port scan. Do not port scan. That's what it means. When you disable the port scan, it's only going to find if the computers are alive. Do not resolve DNS. And then we are going to be doing it for your whole local network. So I'm going to go to SCL. I'm going to be doing there. And I press enter. And should say, hey, host 172.20.1 is up. 03 is up and 02 is up. So in SCL, you should have 3 computers. In situ, you should have more, okay? Was it clear? Questions? ARP? No? Perfect. We are going to be talking later about the /26, but that means the size of the network you want to test. It's a CIDR notation. And that means that in this case, /26 is using 26 bits to define the network and 6 for the host. Let's see an example. CIDR notation, that /number, that's called CIDR notation, defines from the, how many bits has an IP before IP address? I'm not sure if you're not answering because you're afraid of my aiming or, yeah. 32, there you go. So, an IPv6, how many bits in an IPv6 address? 128, there you go. So, those 32 bits that we have, we are going to say 26, in that case 24, are going to be used, if you count 888, that is 24, are going to be used to define the network, and after that, the rest of these 8, we can change from 0, 1, whatever, for defining the host in this network. So in this case, 172.16.0.1 if the first computer you can assign, and 172.16.0.254 it's the last computer, and the 0 is for the network itself. And here we have the case of 26. Instead of 22 bits, we use 2 more for the network. That's the network. Those are the computers in the network. Okay? Was it clear? CIDR notation? Perfect. So you can use CIDR notation in Nmap. Now that we have the ARP and we send ARP packets and we receive, let's use another technique where we send IP packets. Now we left ARP and we send IP packets. And that means that for that, you should put send IPs in the back. Send IP. And then it's going to take some time, and then you have all the computers up. When you are putting send IPs, you are stopping Nmap for sending ARP, and that technique will work on the internet. So there, you can put any network of the internet, and it will work, okay? Questions? I mean, you can, don't, but you can. From your home, I was talking when you are in a coffee shop and nobody knows you with a mask, okay? We're going to be talking about scanning a little bit later. So if you want to see actually what Nmap is doing, which I expect you are curious and you want to know, like, what is the send IP? What is going on down there? For that, we have the packet trace parameter. So please go to your computers, do the packet trace. We are going to be using the pipe less, so we get the output of Nmap, and we give to the less command. And when you execute that, you should see something like this. Do you see something like that, people? Yes? No? Who can tell us what is that? Which technique is being used? We need you to get used to these packets, okay? So look at the screen. If you don't know what you're looking at, this is the moment to understand, to ask questions, to say, what are I'm looking at? What are those numbers? This thing is sent. What does it mean? If you don't know, ask. So who can tell us what technique are we using to find the computers?
I'm sending ping packets to individual IP addresses and I'm waiting for responses.
There you go, very well. So it's not ping packets, it's ICMP echo request, but it's the same used by ping, right? Are you ready? 1, 2, 3. Oh, you lost it. So it's an ICMP packet, and it's type 8, code 0, and it's name echo request. And what I'm expecting, well, if the computer is up and running and allowing this in to get in, it's gonna answer with echo request. So I'm gonna go down, I'm going down, down. Oh, I think it was there. No, down, 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 down. Let's see if I have a reply. Oh, there you go. So from time to time, some computer is sending back, received, an echo reply, okay? Any other technique? Internet? Questions for you too? Any other technique?
So, does the command actually send a request to every IP address, even the non-existent one within the subnet?
Very good question. Is Nmap sending packets to every IP on the network, even the non-existent ones? And the question is, how do you know they're non-existent? And what does it mean, non-existent? That's what you're trying to find, right? Which ones are working? Since you don't know, you have all the IPs from 1 to 254, and yes, you are sending to all of them, because what you want to find is exactly which ones are active, working, or on. So one by one, you are sending, yes. Also, that's why later we are going to use this to detect, right? And say, hey, who is trying to scan me? So any other technique? What do you see? I have another one right there. Internet? Yes.
So we are like trying to send TCP packets.
TCP packets, what type of? Can you see? These are TCP packets. The type is seen, you can see there for the S, and the destination port is 443. So it's sending these SYN packets because if the port is open, you will see later, you see receive something back. And then it's, oh, finally something is going back. So we have there the SYN, we have the ICMP, and if you look at the document, you will have also ACK to port 80 and also ICMP timestamp request, another type of ICMP that actually requests something back, okay? 4 types of finding computers in the network using IP packets, 1 using ARP, and 1 passive, okay? Next one, UDP. UDP, if you remember the protocol, does not require anything back. So if you go to your Dockers and you do this UDP with PU, type of PU, you are going to try to scan those computers, and it's going to say from time to time, hey, these hosts are down and 1 is up. So how does it work? Well, if you remember UDP, when I send something, is not expecting anything back. But in the case of ports, we will see that if the port is open, I'm sending a packet UDP, what I'm getting back? Nothing, right? Because that's a protocol, nothing goes back. But if the port is closed, what I should be getting back? We are going to be looking at ports later, but what we are getting back from a UDP in a closed port is a packet from the operating system saying ICMP port unreachable. So it's changing protocols from UDP to ICMP only to tell us, I'm sorry, that port is not available. And I don't care about the port right now. I care that you answer me. And then Nmap says, oh, the computer is up. And you can see there in the output. If you want to see exactly which packets, you can do the packet trace again. And you will see that it's sending packets to the port 40,125. So why is sending a packet to the port 40,125? What service do you know works there? This is a nice answer, so I will give my last Mando. Mando! I want to go with you. Why port 40,125? Do you know any service there? Is it a web? Is it Sage? Is it MySQL? Well, I don't know any service there. That's kind of a weird port. Yes, Max? Is selected web? Is it intentionally selected because? Nothing is there. Very well, Max. Now it's going to be a Mando. So, 1, 2, 3. Almost. They are very resilient. They have a helmet, so don't worry. So exactly, it's because there is a huge probability that nothing will be there. I don't need an open port. I need a closed port. I need the ICMP back to me. If the port is open, that's bad luck. It's nothing going back to me. So Nmap is finding whatever weird port very high just to have maximum probability of finding a closed port. And then you have here the port unreachable ICMP going back, okay? So, that being said, now we can go to the next technique. We have many people. Yes? Does it choose the port randomly? I have no idea. We need to ask Fyodor, but probably not. Huh? Very well. So you're saying, hey, if that port is fixed, and I know that port, I can actually open that port in my computer and do something, so I'm not answering. And it's actually a very good idea. Like, if that is fixed, you can do that, and then Nmap is going to say, you are not up. I would say that it depends. We can try again. So before it was 40,000 something, right? Yeah, and now, oh, what did I do? Oh, I don't know. Let me reset, because I have an idea what happened. Yeah, so if I do that, it's 40,125, and now again and again. So I would say that it looks like it's not randomized, but probably between versions, I'm not sure. We should check. But it's a good idea, and exactly a way to actually also detect that somebody's doing it, right? So it's like, hey, that's a weird port, right? It's a very good idea. So ICMP, you deserve something. There you go. Hey. ICMP, 3 techniques. Echo request, we already saw. Echo request, echo reply. The second, it's called address net mask request. Very weird, it doesn't matter. You send a packet saying, can you give me your net mask? Remember the /26, right? Like the mask of your network. And then the ICMP packet says, yeah, sure, here it is. Deprecated already. The last one is ICMP timestamp request. For weird reasons in the internet of the 60s, you can say, can you tell me which date and hour and time and second is in your computer? And the other computer says, yeah, it's like 2 p.m. or something. So you can actually try these techniques, and if some computer is answering, you will also have it in Nmap, okay? Actually, look at this one. Somebody is answering the timestamp request. So there are other methods that we are not going to be doing because there are too many, including ACK packets and many more. There are like 9 or 10 different ones, okay? And to end up this part of scanning hosts to see if they're up, while Nmap is running, if you have a long run of Nmap and you're looking at Nmap like that, you can press hotkeys to actually increase the debugging with D and capital D to decrease, and the same with verbosing, okay? So, questions regarding how to find computers in the network is the first step of reconnaissance. First step, which computers are up? We have like 10 techniques. You're going to have to do all of these ones. Internet questions, I mean, in the assignments, in the exams, in everywhere. So be sure you know them. No questions? Perfect. So a little bit on the AI view. So AI can a little bit help you to take a decision on which servers to scan, on which ports to focus, and in general, which are the important things. This is one of the things that AI may help you with. And there is no universal solution, right? So some ideas here are, for example, if you have a knowledge of which IPs, ports, and services are the most probable, you can request the AI to see the results and see which ones to scan. And that can be done by many things. In my mind, for example, decision trees, if you know machine learning, can be used here. Random forest types, light GBN types, many decision trees. You can even have a small neural network that can do that. You can even, can you stop doing me? Thank you very much. And then finding the computers with the most probability of having a security problem. But I'm going to tell you something about the AI things we are going to be doing. Like, AI requires many things, but one of the things it requires is data, a lot of data. You need to train a model. You need to tell the model all your previous experience. So if you want to train a model to tell you which are the hosts of ports that are more important, somehow we need to teach which are the most important, which means, I don't know, logs, scans, port scans, networks, expert, something. That's why training neural networks or decision trees requires a lot of data, a lot of labeling. That is hard. We are going to have one class on machine learning that we are going to be doing this a little bit later in the semester. But in general, one way to jump around this problem are LLMs. LLMs, large language models like ChatGPT or others you have around, can be used because they already have the knowledge. They were trained with a lot of knowledge. That's why the ones that we have here in SCL or whatever other you have, you can ask and say, this is the output of my Nmap. Where should I focus my next attack? And it will tell you, focus here, because the experience of many, many, many people is in that model, okay? So if you want to do that, AI can help you, and actually this is one of the directions that a lot of companies are going, like the human-assisted with AI, like an AI that is telling you what to do, or a completely autonomous AIs are doing this. Next class, we are going to having something about it. So, yes, question from the internet.
Question number 1. Do different techniques give different results? I ran 2 commands, and in one, a host was up, but in another, it was down.
Good question. Yes, they do. And that's why it's so important to run many, because one technique, like the ARP, it's because the computers are answering ARP, but maybe there is a firewall and they are not answering ICMP, or they are not answering some port. So you do all of these techniques, and you will find the majority of the computers. Are you going to find all the computers? No, probably you're going to miss some. Like, there are many reasons why to miss some, but yes. Wait, and we have another question.
Question 2. Would a firewall be configured to block this port 4125 to prevent Nmap scans on the network?
Yes, similar to the idea that, how was your name? Andre had, that it's, you can configure your firewall to block a lot of things. Actually, I encourage you to do, like, you should not be answering ICMP packets. You should not be answering ping packets. You should not be answering a lot of things. Sorry. But if the port is changing when you don't know the port. But in UDP, who is using those high UDP? Nobody. So you can say, you know, UDP more than this number up, block also is going to be fine. Or you just block everything on the internet, right? Who cares?
And the final one, if there is something running on that port, will there be a reply or not?
So in the case of UDP, if the port is open, which means there is a service they are listening, you have no reply. Okay, I'm lying. That's not true. Depends on the protocol. If the protocol is a protocol that wants to answer you, like DNS, you will have something. If not, you are having nothing. If the port is TCP, you should have something. We are going to be looking at that right now in 1 minute. And another question.
Is there some way to either aggregate the messages sent, like the packets we are sending, in order to perform the reconnaissance, or to like send them, I don't know, in some random time periods, span over the, like some time, because it might be, let's say, suspicious if suddenly like there are bursts of
Yeah.
packets to
Yeah.
one type and other type.
Yeah, so it's a good question. Is there any way to aggregate the packets or to randomize the packets so it's harder to identify? Actually, there are, and many tools are doing this. So aggregation is extremely hard. There is no way to aggregate because you need to send those packets. There are some exceptions, and the exceptions are broadcast and multicast packets. Sometimes, depending on the network, you can send one packet to the broadcast address and force many computers to answer you. That's awesome. If that works, one packet, 200 answers. That's extremely hard to detect. The randomizing, I encourage you that you do that because it's very good. The problem is that when you randomize the order, you are going to be finding ports much, much later. You can, instead of having the ports right now, you're going to have the ports maybe in 2 hours. If you don't mind, that's it. And there are options for randomizing in Nmap and in other tools like Mascan and others. Nmap, we don't go there yet, but Nmap is optimized to find the majority of the ports as fast as possible, right? That is optimized for that. Another question? Awesome. Okay, so password time. Internet, are you ready? The password for you is password time. No, is password is. The password is giraffe. Giraffe? Giraffe. I'm not sure about this one. Ask, eh? No, it was super hard. It was not graf. Garafe? Garafa. So let's continue. Is it illegal or unethical to port scan? What do you say, people? Let's have a small discussion on, and nobody asked this before, which I'm very impressed. Like, is it legal? Break. Okay, let's stop here in the break, and after that, we are gonna take the answers. So it's 3:37, 47, we are back, okay? So see you, internet, in 10 minutes. You can go get your beer or whatever you are drinking on the internet. What? Can be a beer, right? I will have a beer. Sorry, and stickers, people. We have free stickers. Look, stickers. If you don't take them, put them in the trash. Let's continue, people. Ready? So we are talking about if it's illegal or unethical to port scan. So who can tell us? Is it illegal? Is it not? Yeah. Yes. So the answer is, and I will give you the catchword, but you are too far away. It's that you are not illegal to port scan, except if you take the computer down, and then it's illegal. Do you agree with, how's your name? František, do you agree with František? Port scanning is not illegal except if you take down the computer? Yes. If you're only scanning the ports,
and the computer goes down because of it, it's not your fault because you were just scanning. That was no kind of attack.
maybe it's your fault, maybe it's not, but the question is it illegal? Fault or not fault? Not illegal. Maybe illegal. How? If it's given by some authority, we are close there. Yes.
Depends on the state.
Depend on the state. Well, depends on the law, people. That's the definition of illegal. So it's not about if port scan is not. What? Somebody? It's not based on intent because it depends in the law. Oh, that's a good one. So it's maybe it's not illegal because if it's illegal, somebody would have to enforce it. Actually, yes, it can be enforced. Like many police officers from Interpol down are being reported these things, and people can go to jail. Of course, if you're home and you press enter and you do one port scan, nobody cares. It's not illegal or not illegal. Nobody cares. The reality is that they will search into this only when it matters. Like, you are getting into the computer, you are breaking something, you are stealing something, and then you will go and see the law and what the law says. Exactly, it depends on the country, on the state, depends on many things. In some countries, it's illegal. In some countries, it's not. Some legislations in US, they say that you should not get unauthorized access to a computer, and access means if the packet got into me, that is you access, and then it's like a very weird definition of access. By the way, it's like depending what you're doing and depending what you're doing and when. For example, a lot of countries have legislations about it's illegal to attack them, it's illegal to port scan them, it's illegal to exploit them, it's illegal to get into their computers. But few countries have any law about scanning out or attacking others. So it depends on where the destination computer is, it depends where the source computer is, and sometimes you are port scanning from a computer in one country and port scanning is illegal in another country, so who cares, right? Except there is a very big attack and then they can ask the Interpol. So, that being said, in most countries it's not explicitly illegal to port scan from the country. In the majority, it's illegal to be scanned because they consider it an attack. So be aware that if you're port scanning a computer in Argentina, it may be illegal in Argentina, so know where you are, nobody's gonna tell you anything, and that's fine. And unless you are taking down half Argentina, there is not gonna be a problem to traveling to Argentina. An easy protection is never to scan the country where you are. That's a very easy, right? If you are port scanning or attacking, try to not attack your own network, enterprise, ISP, or country, because it's the easiest way to get you to jail. It's like, well, if you are doing something that somebody considers illegal and you are handy there, they will search for you. So it's an easy one. Some countries may still not allow scanning from them, depending on the country, and in those you need to check the laws of the country. So if it's unclear to you, do not scan without permission. That's for you, Internet. I don't know where are you from, so please check the legislation in your country. Some countries don't like to scanning from them. Some others, they don't care. As security practitioners and students, it's common to scan internet hosts, like the majority of the cases nobody care. If it's a small one, you just go. If it's extremely high and you're scanning for 3 days non-stop, half the country, well, eventually somebody will notice. You're gonna be important enough that you go on top of the 100 of alerts they have, and then they will say, why this computer has been scanning us for like 3 weeks. And then they will search your ISP, they will call your ISP, internet service provider, and say, I need to report that this IP is attacking us. And because you have an ISP, they have some information about you, like you sign a contract, your name, your phone, your email, or if it's in eduroam, they know it's you because you're of MAC address. It's easy to find you. So try not to do that. And apart from that, port scans can disrupt the host. So apart from legislation, you may take things down. So please pay attention there. OK, so interact with a server. How do we interact with a server? The interaction with the servers is given through ports. What does it mean, ports? Port is that there is a mechanism, there is a software that is listening there, and then because it's listening there, we are going to be sending a packet, we are going to be interacting, and then we are receiving something back. That mechanism is a port. So how do you know the states of the ports, TCP and UDP? Well, in the case of TCP, this one here, if the port is open, it means that it's accepting connections. Then if I send a SYN packet, I'm going to receive a SYNAC, okay? The traditional handshake, SYN, SYNAC. Then you know the port is open. If the TCP port is closed, you're going to receive a reset, SYN reset. In the case that the port is filtered by a firewall, by your ISP, then you are not going to be receiving something, or you may receive an ICMP filter message. Depend on the configuration. Most of the times, no response. If it's unfiltered, that means that the reset or the SYNACs are going in this ambiguous context. So sometimes you may have like the port is no open, but packets are going through. So Nmap has techniques to also map if the port is allowed in the firewall, even if the port is closed, okay? You may see that, hey, that port is not answering correctly, but it's answering something. So you know it's unfiltered. And in the case of these opens that the state is open and the TCP descriptions say filter, well, you cannot determine if it's open or closed. This is the case for UDP. So let's do the UDP part. If the port is open, UDP is accepting packets, that means that there is no response, okay? UDP goes, nothing back, as we said before. If the port is closed in UDP, we are going to get back an ICMP port unreachable message. We saw that in tcpdump. If it's filtered by a firewall, by a router, then there is no response, sometimes an ICMP 13 message. If it's unfiltered, again, we have no response, and the same with open. So you see the problem in UDP. If the port is open or filtered, the same type of answer, no answer. So no way for Nmap, by default, to see the difference between an open port and a filter port, okay? So let's try some of these ones. First technique, search for ports in TCP, fast, the top 100 ports, that is -F. So please try this technique, and you should see, oh, I am losing my terminal, reset, there you go. You will see ports, discover open ports, discover open ports, discover open ports, and then you should see a report like this. So please try internet here, and you should see the computer, and then, in this case, 93 filtered TCP ports because there was no response, and then we have open ports. 113 is closed. That means it got a reset. The rest got a SYNAC, and this 93, no response. Okay? Was it clear? Yes? Opa. The top is because Nmap has a list of the ports that are most probably open on the internet. They did this a long time ago, but actually asking the people to submit the results of port scans, and they took thousands of port scans of people on the internet, and they compile a list of the ports that are most probably open. And then they prioritize those ports. That's why it's the top 100, okay? If you only want to see the open ports and not the close and the filter, you can do --open. If not, you can see every state, okay? If you don't want to search for the top 100, but by default, if you don't put the --F, you will search for the top 1,000, okay? So you can also do that. I'm gonna do it in CyberLab. And that's gonna be the top 1,000 ports, okay? Questions? Ports? No? Let's continue. If you're searching for one port in TCP only, not all the ports in one computer, but one port in many computers, we call that a horizontal port scan, because you are going like that, one port, all the IPs. The one that you are doing all the ports in one computer, we usually call a vertical port scan. It's like a terminology. So we can say, hey, Nmap, and I forgot to say the SS. I'm sorry about this one. SS means do a SYN type of scan. SYN, remember? SYN, SYNAC, ACK, or SYN reset. That is a SYN type of scan. If, actually not true, if you are using this type of scan as root, you will have, I'm sending a SYN packet. If the port is open, it's sending me back a SYN ACK. That means the port is open, and that means the computer is up. In this type of scan, Nmap is not sending the last ACK, it's not closing the connection. And why is doing this? Because if I'm sending a SYN, I receive a SYN ACK, and then I send an ACK back, the connection is considered established. The operating system is gonna mark this connection established. It's gonna go into the logs, it's gonna go into very easy to detect. If I do not close the connection, if I say SYN, SYNAC, and then I just don't answer, the connection was never established, so logs and the operating system will not report this. It's like, yeah, nothing happened because the connection was never established. So it's a little bit more stealthy, a little bit more hidden. That's why the capital S is coming from, stealthy attack. So the SS is this type of scan, and you can put the specific port you want, in this case port 80 with -P. So that is scan please with the technique of SYN scan all the ports 80 in that range. Do you see how I put the range? 1-10? That's another way for you to put the range of IPs you want to scan. So in that case, 10 computers. If you do that, you will find only the open 80 ports of these computers. Do you see it? Did it work for you? Yes? Perfect. So, after this first port scan to find open ports, it may be that some ports are not showing for you. There can be differences, internet, and that's because, remember that as security analysts, as attackers, we are not respecting the protocols. The protocols are meant to be implemented by operating systems so we can communicate, blah, blah, blah. We are attacking, we are breaking this. We are finding the small differences between the packets. That means that sometimes it may not work. This is not deterministic. So sometimes the networks are slow, the packets are lost, something happened in the network, a firewall, a router. So it may be that you don't see the same results over and over again. And this is important also for later you in the assignments and the exam. Sometimes you're searching for a port and you're just too fast and you're missing the ports, okay? So timing is gonna be critical here. How do you search for all the ports? We just said -P, that's the ports, and instead of giving a starting point, a port, and an ending port, like here ports 2 to 8, you just ignore the start and the end port. So -P means all the ports. That is gonna find literally all the ports, which is awesome, and you may need that, but be careful, it can be very slow. It's thousands and thousands of ports, okay? I suggest the best for you is to practice, practice, practice. Go into the Docker, scan, scan, scan. See the timing, see how many packets are lost, see how you find stuff, right? This is a moment, internet, go practice. Go put your fingers there. So, Other ways of finding ports. We already saw the scene scan. You have also the ACK scan. Instead of sending a scene, you send an ACK. Weird, but sometimes go through firewalls. You also have the TCP connect scan. This is the traditional SYNC ACK, so you are closing the connection. And you are doing this when you are not root, because if you are not root, you don't have the power to send individual packets. You cannot do that. It's called raw socket. You cannot do that. You have permission. So if you are not root, you cannot do the SS scan. This scan only for root. If you are not root, you need to do this one. If not, you don't have permissions, okay? It's going to be a little bit slower, but it's going to work. And then we have other many types, and somebody, yeah, you were telling me about others. These are a little bit oldish, from the 70s, the null scan, no bits on, the Christmas scan, just the bits on and off like a Christmas tree, the thing one. These are all, they're fun, they don't work anymore. So you can try. This is like just playing with the bits to see what you can find out there, right? And then we have some new ones for SCTP, very, very weird, okay? So, TCP ports, questions? Open ports? Nothing? Remember to practice, people. Practice. Go and find ports in computers. See. You can have computers around. You have your printer. You have your Wi-Fi. If you have an IP address, be curious and go and find the ports. Okay? Internet? Questions? Let's jump into UDP. So UDP, another set of ports, because it's another protocol. How do you search for those? And that is capital U. So you can do this nmap command, and you can go to Strato Cyberlab, or if you are, oh, this is still scanning, in your CTU Dockers, and you press enter, and you're going to be finding, by default, the top 1,000 ports on UDP protocol. If you saw my command, I'm using a new parameter called capital T. Capital T means the timing. And 5 is the fastest timing on Nmap. And that's because UDP is extremely slow. Who can tell us why UDP is very slow to scan? Yes? Can you start again?
The packet in UDP is smaller than TCP, and it does not have as many headers as...
That's a good answer. The packets in UDP are smaller than TCP, and doesn't have some answers. But doesn't mean that should be faster? Smaller packets, less data?
But it sends multiple packets.
Why it sends multiple packets? It says sends multiple packets. It's a good answer. It's not because of that, but I like it. Actually, because of that, it should be faster, right? But UDP is much slower. Why slower?
It needs to time out before it can determine.
It needs to time out before you do it. That means that because there is nothing expected to come back, it doesn't know when to stop waiting. It's like, I'm sending a packet in UDP. And you don't know. So when you stop, when is enough? When is the packet going through the internet and back? So at some moment, Nmap is like, well, I'm going to stop waiting right now. And that's why you have messages there with a timing. It's like, yeah, I'm increasing the send delay because it seems that nothing is open. I'm going to be slower. So Nmap is being slower to guarantee that it's trying to to find the open ports. It may fail. You may have to wait more. So timing is critical in UDP. The majority of the time, the people do not find UDP ports open because they don't wait enough for your exam, okay? So how do you find which service runs on each port? So because a service is an application that is listening in some of the ports, you can actually try to find what service is there. Okay, port 80 is open. What does it mean? What is there in port 80? And for that, we can also use Nmap, and we can use -S capital V. And that means please try to find the version of this service. Oh, Max, oh. Yeah.
Can we use the ICMP reply to establish the timing baseline that we should expect?
Very good. Can we use the ICMP packets bags to put a baseline on the timing? Yes, you can, and that's what Nmap is doing. If you check the packet sent by Nmap, it's very smart. It's first trying to send any type of packet to find if the computer is up. From ARP, if you're in the local network, to TCP, to ICMP, whatever. And it's searching for the most common ports, 443, 80, DNS, 53. If any answer goes back, then has a timing. And then it's like, okay, I know how far away you are, now I'm going to adapt the timing. That's why Nmap is speeding up, slowing, right? You can also force it, by the way. So yeah, that's something Nmap is doing. So in this case, we are going to be asking in your local network, can you show me the versions of the ports? So I'm going to go to your Dockers, please. Search for versions in your Dockers. And there you go. Who can tell me the version of the Docker? Oh, the version of the Docker. The version of the service. SSH. SSH is the service. What else? 9.61. So if you look at this, it says service SSH, which is a protocol, is good. But then you have the version. OpenSSH, 9.6, P1, Ubuntu 3, Ubuntu 13, blah, 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 blah. This is because it's talking with this service and finding more information about it. Now you know the operating system, now you know the service, now you know the version of the service. Critical information for exploiting later, okay? So the PN, yes, it means treat all the hosts as if they are up. That means please do not try to find if the computer is up or now. Like, consider all the computers up. That means the PN. That guarantees that you are going to go to all the IPs and try to find the port, all the ports there that are open and the version. Some parameter for you. Another one you can do is with port 80. So you can specify the version only on port 80, consider the computer up, and timing 4, which is a little bit fast. So if you do this one, yeah, I'm going to stop you, UDP. Wait for me. Be careful with the UDP, because when you do that for the assignments or the exam, you're going to have to wait. So you have to be very good at this one. In the case of the port 80, it's going to be connecting. Now it's scanning, scanning, scanning. Already we know that the port is open. We already know that the computer is up. And after that, it's saying Cloudflare HTTP proxy. And like that, you can find more things, okay? That is the version number. Questions about this one? No? Perfect. The next stop is Nmap scripts. Nmap, if you remember, has a Lua language that can be used to load scripts in real time. So while Nmap is working, Nmap is a compiled program, you can actually load Lua, which is interpreted language, scripts inside Nmap. Very versatile, very dynamic. You can go and program your own Luas right here, or ask an LLM to do it for you. So we are going to be loading scripts with SC, and in this case, because we do not have any parameter, it's going to be using the default scripts. So if I use this command, please do, I'm going to connect to which port? 443, that usually is for which service? HTTPS, very good. So I'm going to scan that. I'm going to ask Nmap, hey, once you go to this port, try to find the version, but also speak the protocol, interpret the protocol, send stuff, send questions, whatever you need. I don't care if it's a MySQL, Nmap knows. This is, I don't know, something more, Nmap knows. And at the end, it's going to show you all the information. So look at this. Hey, this is 443 and SSL HTTP, and we have the TLS next proto neg, that is H2, the date, the TLS randomness that does not represent time, Then we have the TLS Alpen, that is H22, the certificate that has this subject, the subject alternative in the certificate, the public key, the signature algorithm, all the information that you can find about the protocol, Nmap knows how to get it. So this you can use in every port to speak and to find DNS, POP3, MTTP, okay? Internet questions? No? Got you. So the same you can do, for example, with 22. I'm going to be doing this one in SCL. It's going to be talking, and look at this. In the case of SSH, you can have, well, yeah, this is closed, so probably not. Oh, this one. You have the SSH host keys, so you can see directly there for the SSH port, okay? Remember why we are doing this. We are doing this because this is a class about reconnaissance. You need to find all the information in the network before attacking it. You need to find IPs, services, ports, numbers, versions. If not, you cannot attack correctly. Later on, you're going to be exploiting this. No exploiting if you don't know what is there. Finding versions is one way. Then you can actually, now that you found all this information, one way is to use Nmap, like we said before, and other scripts. Another way is actually to interact manually, like you, as a human. So let's try this one, okay? Internet, that is, if you remember, last class we used ncat. We are gonna be doing it again. Last class we interact with HTTP. Remember? ncat, yes? And you were like talking like a web browser. Now we are going to be doing this, but with emails. So if you are here as an internet student, you can connect also here in the CTU. Please go to your Dockers and use ncat --SSL. That means on top of the protocol is going to be an SSL layer. SSL layer. So you have to speak SSL. Then the IP, and then the port. What is the port 465? It's the port for the encrypted SMTP. And SMTP, Simple Mail Transfer Protocol, is the protocol for sending emails, not receiving emails, for sending emails. So this port 25, usually for receiving, sending emails, 465, the encrypted version. So if you do this command, and you press enter, you will have something say, hey, something.com, exim, that is the version of the service, the service, 498.1. We do not authorize the use of this system to transport unsolicited and or bulk email, and now I can talk. What are you going to say? Well, you can say extended hello, I don't know, test.com, and it's going to tell you, okay, hi, test.com. These are the commands you have. So please try, connect with SMTP, internet, connect with SMTP, and speak SMTP. Now that I told the service who am I will try to send an email. So the next command, if you follow here, is mail from. So now I'm going to say mail from test@test.com, enter. It's going to say, okay. And now I need to tell where the email is going. That is RCPT, recipient, to, I don't know, test@admin.com or whatever. Unfortunately, we are not in the 70s anymore, so the system is going to say, well, you know what? If you want to deliver there, I cannot do it unless you actually authorize. Like even if you try. And here says the account or domain may not exist, they may be blacklisted or missing the proper DNS entry. So yeah, I cannot send there. I can try to send to somebody else, LCPT to, what about gmail.com? And I'm gonna say, oh, a recognize command. Okay, let's reset and start again. Do I have reset? Reset? Reset. That is the reset. Now I'm gonna start again. Hello, test.com, mail from test@test.com. Receptor is test@gmail.com. Whoever has that address. and then it's going to say, no, 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 you need to authenticate before sending your email, because that's what spam is, right? Sending emails without this authorization. Could you talk the protocol like this? Did it work for you? I'm going to give you some time to try. Please do. Go type, internet type. Make sure you know how to speak SMTP, please. By hand, like a real attacker. Go there, exploit it, try to find, log in. Well, in here I didn't tell you how to log in, but you can also try to log in. Actually, a nice way, please keep doing it, is to try in this computer. So unfortunately, this is only for CTU students, not for the internet. So please, internet, continue with the previous one. If you are inside CBUT, CBUT allows you to talk to the SMTP server of CBUT, because they are very nice people. So actually, you can connect to this computer, and you can actually speak inside the university and say, hello, test.com, and then you can say, mail from martin@gmail.com. Okay, and the recipient I'm going to be using is somebody called Rigakmar, some Maria Rigaki, who knows, at fel.chbut, and says, okay, I'm okay with that one, because it's CBUT, and you are inside CBUT, I allowed you. And then you can do data, and now we are going to write the email. So the first thing in the email is going to be subject, hi there, I know you. Oh no, I'm too slow. I need to start again. So wait, I need to start again. Hey, hello, test.com, oh, something like that. A mail from sarasa@gmail.com. And then I'm going to send to Mari, and then data, and then subject, I know you. And now I can write, hi there, how are you? And when you want to send the email, you just put a dot. And that's it. The email was sent. So please, can you try to send an email to Mari? They have? Oh, she already has some email. Please, this is a moment. Go tell Mari how much you appreciate that she doesn't know who you are. There is no, if you pay attention, you can put any email you want. There is no authentication for sender, so you can put their mail from whatever you want, like decan at rector or whatever. So it's going to work because you are inside the university, sending 2 university addresses in here. So please try, learn how to do that. Also, ethically, please do not abuse it. Remember our deal in the first class. You are learning how to attack, that means responsibility. So please learn, try, practice, teach others, do not abuse your powers. So Mari is going to be receiving email, and
Someone asked for a free A, but I don't know who you are, so sorry.
she has free stuff, but you should send your credit card so she knows who you are. Okay, questions about connecting to SMTP? Internet, questions about connecting to SMTP? I'm sorry you cannot, yes. Sometimes you have connection exceeded time or broken pipe because for security reasons, the protocol is not waiting for you. It's not for humans, it's for computers. So if you are too slow, you're out. You have to type faster or do a script, right? Another question. What does the hello? So when you connect there, you need to say hello, which is like hello, but you can have the extended commands, and they are smart, so Bluetooth extended hello. So it's a way of starting the communication and receiving what's possible or not possible. The what, sorry? The mail from? So, When you say hello, like test.com or something. Yeah, it's like kind of, they wanted to say something like, where are you coming from? Like, originally should be, hello, CBUT.cz, like, I'm coming from the university, because people were very nice in the 60s, like, not anymore. So they wanted you to say who you are, right? Questions? Send emails, internet, you can try. Max?
When I send an email to myself, I don't see who was the sender. So what is the point of the mail from?
You don't have the sender?
Yeah.
Oh, you should have the sender. Do you have the sender? Wow, that is very, very weird. No, you don't have doesn't know your own email. So how does it know? No, that's extremely weird. Unless you put your email, doesn't know, right? Very weird. I can imagine that something not broken, for example, sometimes you have a missing space or something and the protocol breaks. But remember that what is there for sure is the source IP address of whoever sent it. So if you abuse this, the university can go to the logs, get the IP, get the EduROM, get the Wi-Fi connection, get your MAC address, and they will know it's you, right? So that is that. Okay, you can also do this with online, with SSL. So in that case, you can connect to ports that are having the port encrypted, and that is with the SSL, and you have the same situation as before, okay? Exactly the same situation. Also, you can try with the POP protocol. The POP protocol is the post office protocol, the protocol for receiving emails, not sending, but reading emails. In this case, is port 110. If you encrypt, is port 995. So if you connect to a POP protocol, you can read emails of people if you know the user and password. So you can go here and say, user, I don't know, admin, and then the passwd, it's admin, and then, pass the admin, pass, okay, help me, Obi-Wan Kenobi. I'm sorry. Help me. No, help for me? Boo. User, admin, and pass. I'm missing something. Admin, pass, admin. Weird. Okay, maybe somebody can help me. If you know the user and password, you can put it there, and then you log in to your own account. You can do this in your CBUT account. And then you will see your emails, and you can type, and in the console, see your emails, okay? That's how your emails work in your computer. I mean, not the web ones. So all of this is to know that you can speak protocols by hand with Nmap. And Nmap can do much more. We are not going to go to everything here, but you can use the T parameter and be very, very fast when you're doing this. You can be slower if you don't want to be detected, and many, many other things, okay? Extra packets, fingerprinting the operating system. You can do everything together with capital A, and many, many other things. In particular, pay attention to the -on to actually store the result in a file so you don't have to copy-paste everything, okay? And you have there what probably is the fastest Nmap you can have ever. That is like tuning every parameter to be very, 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 very fast. Yeah, it was 0.3 seconds. The problem with these very fast Nmaps is that you are at risk of missing packets. So you can be extremely fast. Be careful that some ports are not going to be there, okay? So you have there the parameters for this. Questions so far? Port scanning is going to be stop here, no more port scanning. No questions? Okay, so let's do a jump of topics now that we have this reconnaissance, we find the computers, find the host, we did a lot of things, we are going to be jumping into passive scanning of the network. How to analyze a PCAP file, how to go and see packets in the network and understand what's going on. And that's going to be your goal from the rest of the class. How to get these packets and identify if you are under attack or not. You already scan others, you have your PCAP file. Remember at the beginning of the class, now we need to go and see if you can look at those packets and understand what's happening, okay? Now we are going to be a little bit going into defense. So for doing that, we are going to be using again tcpdump, and we are going to be using a particular PCAP, all of us together, that is called training capture 001, on the internet and here, everybody. And you can do this command in SCL, or you can do this command in the Dockers, it's going to work. So tcpdump, we are going to be using the parameter -ttt for this. That means to print the complete datetime of the packets. We are going to be using -n, not to resolve the DNS. And I'm going to do a parenthesis in here. Who can tell me why, now that we are analyzing a capture of packets that we don't know what's there, can be an attack, can be malware, can be benign, can be my computer, I have no idea. Why I'm asking not to resolve the DNS? What is the problem with resolving the DNS? Do you know what I mean when I say do not resolve DNS? Anybody's lost?
Maybe the server is like malicious, the address, the DNS address.
Which address is malicious? Maybe the address is malicious. The address. So if it's an attack, but what address are you talking about? The domain name. The domains in the captures. Okay. So you're saying that if the capture has domains, those domains may be malicious or belonging to an attacker. Very, very, very close. The problem is that those packets are, if you look at the PCAP inside in the TCP layer, you only have IP addresses. Then you go to DNS and you have the domains, but tcpdump is not going to get the domain from DNS. It's not going to even interpret DNS. You only have IP addresses. So what I meant in that DNS resolution is when you open the file with tcpdump and you find an IP address, do not get the reverse DNS of that IP. Remember, we did this last class. We did this, dig-x, and then we did something like some IP, and then you can get the name. Well, here doesn't have a name. What is the name of 8888? Yeah, this one. So 8888 is called DNS.Google. What we are going to be doing with -n means every time you see an IP address, please do not resolve the DNS. That's why we are telling tcpdump. And it's very close to what you say, but it's not exactly. But the similarity is that if this is a packet capture of a malware attack, those IPs will maybe belong to the attacker. So if you are trying to do a DNS resolution, you are going to be going to some DNS server that is going to ask some DNS server belonging to the attacker in a weird country like Argentina, and then it's going to say, hey, can you tell me the name of this IP? And then the attacker will know, oh, somebody is analyzing my traffic because they came to me. Got you? Everybody? Was it clear? Ooh. Is it okay? The cookie, the chocolate, I mean. Oh. So, no questions? Got you. So, copy paste the command, please. Go to any place. I'm going to be doing this in SCL. Internet people, you should see exactly the same. Every line is a packet. One packet, one packet, one packet, one packet, one packet. First column, the date and hour where the packet was received. Date and hour. then we have protocol, and then we have information about the protocol. Source IP, source port, destination IP, destination port, and others. Okay? Everybody? Who can tell me what is that first packet doing? What is the purpose of that first packet? Asking the network for the IP address I want to communicate with. Do you agree with, how's your name? Matthew? Yeah. Matthew. Do you agree with Matthew? Very well. So it's saying, is it not asking for the MAC address of this IP? So it's not still trying to communicate with anybody. It's saying, hey, I'm sending another packet requesting who has that IP. Okay? That's the destination. But who is telling this? Who is asking? Can you see the IP of the computer that is asking? Who told this? 0000 told this. Who is 0000? 0000 means broadcast. Very close. It's not, but thank you very much. Universal receive, also no, but thank you very much. Ah, there you go. That IP is not broadcast, it's not multicast, it's not a network. It means I, the sender, do not have an IP yet. The computer does not have an IP address, and I need to know who has the 10.0 to 16. Why? Because I want to put that IP in my computer. I want to assign it to me. That is a collision detection. I'm checking, hey, anyone here has the IP I want? No? Thank you. I will assign to me. One of the mechanisms to find that in the network. Second packet. Who is the sender? Who is the IP sending? What is the 000? It's good, it's good. What is it? These ones, very well, these two dots are a specific notation in IPv6 addresses. When you have only zeros in IPv6, you can actually compress the address, delete the zeros, and just put the colons. Remember, an IPv6 address looks something like that, right? So when you see two columns together, it means that it's all zeros. So that is exactly the same packet as before. The 0000 IP is sending to a specific, that is a very specific multicast group, an ICMP6 message saying neighbor solicitation, who has some IP. Okay? Do you see this? Yeah.
I have a question. You said every line is one packet, but ARP doesn't operate on like third layer, so...
I didn't say third layer, I say a packet. You can have packets only with Ethernet. Only with Ethernet and IP, Ethernet IP, Ethernet IP TCP, Ethernet IP. Like, it depends how far up you go in the packet. All of those I will call packets. If we go technical, we have frames and others. But in the network, you see something, and the amount of headers depends what you have, right? Something more? Next packet. We have another IPv6 packet. Remember what I told you, your computer is doing IPv6 even if you don't know. Now we are having the IP that we assign ourselves, and now we are sending to another multicast group. Hey, router solicitation, I want my router. Hey, I want to get into the listening report version 2. Hey, I want a listener report version 2. Again, this a packet ARP, but now I want to know who is the 10.0 to 2, but now the tail is 10.0 to 16, see? Assign itself the IP, because nobody had it. And the next packet is the replay from 10.0 to 2, probably the router gateway, saying, hey, this is my MAC address. Do you see how the story moves forward? Each packet is telling you what's going on in the network, right? Then we have a DHCP solicit. DHCP is the protocol for actually talking with the router and DHCP server in your network to find information like DNS servers, mail servers maybe, restrictions in the network, sometimes your own IP, right? Protocol import 547. So all these are packets telling you what the computers are doing. If you pay attention, these packets at the beginning are the traditional packets or for a computer that is booting up. The first time the computer starts and is starting to search, hey, DHCP, can you give me an IP? I have an IP I want. Do I have a collision? Which is my gateway? Which is my... Those are the packets of a computer that is booting up. So when you see that in your mind as a defender analyst, you say, that's okay, that's a computer booting up, okay? Was it clear? You need to practice this a lot because a lot of the things you are going to be doing this semester is looking at packets, attacks, what's normal, what's not normal, how can you use it. Those things you are going to be looking at the network. So, apart from these commands, and here you have a beware extra for the internet. If you have a different time zone, we can talk about this if you have the issues. The next one we are going to be doing is capital A. And capital A is going to show us the content of the packet, because so far we didn't see any content. Now, with capital A, please, if you press enter, you will see things like this. Those are the representations in ASCII of the content. Because the content is not for humans, you will see dots here. Dots. That means, yeah, we are characters because this is not for humans. But if you go down, for example, in the DHCP packet, you will start see some things you recognize, like Win1, which is the name of the computer, Microsoft 50. If you go down more, you will see other packets. I'm going down until something you can recognize. Look at this one. This is a DNS request to 8888 with 53. Okay? Do you see this? Questions with these ones, looking inside the packets? If you use -- number, you're going to have there the number of packets if you want to. So, let's analyze a little bit of these ones. Your goal is to understand the protocols. Your goal is to know the protocols and to see if this capture is an attack or benign, okay? That's going to be your goal. So, some of the filters you can use for this. If you want to see UDP packets, you can put UDP there in the filter of tcpdump. So in this case, the same tcpdump, but you put only DNS packets. If you execute that, you will see all the packets going to UDP protocol. DHCP, answers, you will see DNS in here. So here you connect to the DNS of Google, resolving the computer called www.msftnssi.com. Benign or malicious? What do you say, people? Did you find an attack? And this is normal. Yes, 8888 is Google DNS. This is the DNS you are connecting to, but you are asking for any domain on the internet, and that domain is www.msftnssi.com. So DNS to Google is benign, but what about that host name? Microsoft, there you go. So this is Microsoft NSCI, Network Connector Status Indicator. Every time you boot up a Windows, goes to Microsoft, and it's telling you, hey, I'm here, and then you have like, you have internet, yes or not, or whatever. So that is that DNS request. You can see here the answer. See the answer? 8888, source IP, import 53, source port, is answering your computer 10.02.16 in the source port you used before, this one, the source port usually pseudo-random, and answering, hey, you were asking for that domain? Yeah, the answer is a CNAME. In DNS, a CNAME is like a link, common name, a link. And it's like, yeah, it's exactly the same if you're asking for www.msifcom.edge.net, which is the same as asking akamai.net, which has the IP address, this one, an IP address, this one, an IP address, this one. Okay? So you can see how the protocol moves forward. I'm going to go down more, so you see all the packets, and eventually you see other domains. See? timetoinbout.com. Somebody is resolving this. And the 8888 says, oh yeah, the IP address of that domain is this one here. Okay? Could you see this? Questions? Internet? Yes. You will not see that, except if you are doing it on purpose, right? Yeah. So, other filters. Instead of UDP, you can filter for ICMP. What about filtering only for the DNS of Google? So I'm going to do this one. So I'm going to go here. Instead of UDP, I'm going to be putting host 8888. See? And now I only see what I'm sending to 8888. What about what is in 8888 and UDP and not port 53? What about other combinations? So you can do ORs and you can do ANDs. Filters, okay? Filters here. There are many things around in filters, and that's something that you can go and check. So we're out for the break? Late? We're late for the break, right? Oh, okay. Yeah. So let's finish this one and you have the break. So ABI view here, the ABI point of view. AI can mostly help you by understanding the practical protocol. So far, there are, as far as I know, no AIs that can go and do the analysis of the tcpdumps or the Wireshark packets with you and really make a difference. Like humans, we are much better at that. We can recognize patterns and normals and benigns like much, much faster. So that, so far, AI has not advantage in here. Questions before the break? Okay, let's take a break. At 56, see you back here. Internet? Okay, let's continue, people. Internet, come back from cooking pancakes or whatever you're eating on the internet. So, now that we saw tcpdump, and let me say this again, please practice. Open packets, open pickups, go and see, spend the time looking at the packets. If not, the next time you see those packets, you're going to be very lost. And it's like, what was that protocol, right? So get there and practice. Now we are going to be using another tool, not in your Dockers. If you see the thing here, it says in your host computer, both the internet and here in the class. Open in your computer Wireshark. So you should see something like this, like the beginning of, I cannot make this, yeah, Wireshark. And we are going to be opening a pickup that is the same pickup as before that you can download from any of these two places. So please download the pickup in your computer so you can open it with Wireshark, okay? So you do that, and then you open, and then you should see something like this. So I will give you some seconds for everybody to have Wireshark open with the capture training 1. Nobody's moving, so I guess you have it open. So we are going to be using Wireshark. Why we are going to be using Wireshark? Because we like it? No, of course. It's because it has a very nice interface to understand the protocols. So if you are looking at a capture that you want to see what's inside, you want to understand the details of the protocol, Wireshark is going to be very nice for that. You will see very easily what's going on. What is the problem of Wireshark? It doesn't have many, but the main problem of Wireshark that is it's not able to load very big captures because you need to put this in memory. So if you have a PCAP that is 200 gigabytes, you cannot open that in Wireshark unless you have 200 gigabytes of memory. So it's very good for small captures, but when you have attacks, port scans, DDoS attacks, it's extremely hard. And then you have to wait and filter. That's why you have both tools, tcpdump and Wireshark. Wireshark is good to understand. tcpdump is going to be very, very, very fast, okay? So both tools there for you. Now that we open Wireshark, that is this extremely popular network protocol analyzer, you will see the packet list. This is here in the middle, the packet list. Then here in the bottom right, you have the details of the protocols. Let me move this up and choose a packet for you here, right? You can see the protocols. You can open and close protocols and see TCP and all the features of TCP, and then IP and all the features of IP, and it's very nicely interpreted, so you see here. And on the right, you have the raw packets. This is the packet on the network, and you can see exactly which bytes are which, and you can click on the bytes and find what is this on the protocol, okay? Very, very, very handy. So, that being said, we are gonna configure the columns in Wireshark because we need to see the same columns. So right-click on any column name here, right-click on any column name, right-click, and now we need to choose some columns. In particular, be sure that you have packet number, the time, the source. We are going to be putting the source port because I think you don't have it, right, by default? Source port, you don't have it, right? Okay, we are going to be adding source port, destination IP, destination port, protocol, length, and info. So when you right-click in here, you should be choosing those. I think you don't have a source port and you don't have destination port. Am I correct? No, I think you have destination port but not source port. No? None of those. No ports, and you have both. Okay, let's make sure everyone has everything. So, for adding the source port and the destination port, Internet 2, you go to column preferences, and inside column preferences, you're going to click plus to add something, plus, column preferences, plus, and then, after clicking plus, you go to the bottom. Yeah, I have to. If you go to the bottom, yes.
Do you need to enable some special event settings because we only see few columns. We don't have so many others.
In here. Yeah. No, it's fine. These are mine. It doesn't matter. We are going to be adding more now. Yeah. So it doesn't matter how many you have here. But if you put plus, here in the bottom you have a new one. So there is a name of the column. So you double-click in name of a column, and you put, for example, source port, like support. Okay? New name as port, for example, for the source port. And then, if you click here that says number, if you click, you will be able to choose what you want to show. And what you want to show is the source port and resolve. Source port and resolve. Okay? Help. You can say, please help me, Internet. So, column preferences, plus to add a new one. You put a name, then you click source port and resolve. After that, you are good to go. The only thing that extra you can do is to move this column wherever you want. So I'm going to be putting next to the destination. There you go. If you click OK, you should have now a new column as port with a port. Okay? Do you have that? Perfect. And you can do the same for the destination port. So column preferences, plus, going to the bottom, the name is going to be the port. Instead of number, you click and you find destination port and resolve. New one, the port, destination port and resolve. This one. I'm not sure. I think that this one is automatically resolving if it knows and not if it not. I'm not sure. I prefer unresolved, so I always have the number. But you can try both and see. Okay? Destination port, and then destination port unresolved. Everybody? Internet? You click. Then remember to move it to wherever you want. I'm going to be put it close to my destination IP. Then you put OK. And you should have here your dev port.
Yeah, when you do the resolved, this is Wireshark interpretation of what the port is based on the standards, right? So if you say port 22, it will replace it with SSH. But this can be misleading because sometimes you might run other service on port 22, which is not SSH. So when you see unresolved, it will show you the port number, and then you can investigate what it is based on the rest of the information. So it will not mislead you in a way.
Okay? Ready? Ports, you have the columns, everybody? So, now that you have the columns, let's do some things in Wireshark. First, menu statistics protocol hierarchy. Menu statistics, and then protocol hierarchy, okay? In here, you will see all the information about the capture. How many packets are of Internet Protocol version 6? How many packets of Internet Protocol version 4, 96? How many UDP? How many TCP? How many hypertext transfer protocol? That's the web. How many real-time transport protocols? Okay? Could you see this? Very high-level overview of what's inside this capture. Those protocols, those packets. If you see something that is interesting for you, you will see, I don't know, an attack, SSH, you will see MySQL, I don't know, whatever you're searching for, okay? Questions? After this protocol resolution, we can see conversations. So again, menu statistics, conversations, conversations, and these are very nice because are every time a computer IP address from a source port is communicating with another destination IP address, source port, with the destination IP address, destination port, all the packets coming and going between these two computers, two ports, are grouped together in a connection. So you can actually, or conversation here. So you can actually see, oh, these two computers, they send 266 packets. Can you see that? Between these two ports, 80, 10 packets. How many bytes? How many everything? So it's an aggregation of information. Very, extremely useful to know. Actually, look at this. The whole capture was summarized in 15 lines. Very fast, you can see only one computer source IP, 10.0.2.16, from a lot of different ports, communicating with all these computers on the internet, port 80. Can you see the weird port? This is port 80, which is web. Can you see the weird port in these communications? HTTP, it's the protocol, but what would be the weird port? I guess you mean 80, right? So 80 would be a port you know. What would be a port you don't know? Like, what is that port number there, and who the people is talking to that one? Look at the first connection. There is a port 8529, okay? So what we need from you is to start looking at this and practicing, understanding the information, understanding what you're looking for, What are the weird things? What are the anomalies? What are the attacks probably doing? Is this an attack? Is not an attack? So from a connection going to port 80 and a connection going to 8,529, I would say that's probably much more anomalous and suspicious, because normal people go to web pages. They don't go to this weird port that nobody knows what it is. So if I need to put my energy in analyzing this, I will first analyze that one because it's like very weird. See? Okay? So moving forward, identify a connection and see its content. So how you do that? If you get out with escape, you will see the packets, and as before, you see the first one is an ARP. Then we have a lot of ICMP6. You remember we saw this before. I will make this a little bit bigger. Some broadcast one. Remember the DHCP. Exactly the same we saw before. Now, after connecting to the DNS server and asking for the IP of Microsoft, there is this green connection. This green connection is the client computer 10.02.16. I'm going to close this. Going to the computer called akamai.net. I'm not sure if you have the IP or if you have the name. I think you have the name. So let me do exactly as you have right now. We are going to be doing view, the name resolution, do not resolve the network address. Let me see. I think you should look at the IP, right? Yeah. So this connection is going to the IP 66 something, and the port is 80. That usually is the web. So how can we see the content? And for that, what you do is right-click and follow the TCP stream. So you pick any of the packets that you want to analyze, right-click, follow TCP stream. On the packet you like, right-click, follow TCP stream. Got you? Got it? So if you do that, you will see a screen with the content of all the conversation. This is not one packet. These are many packets. The whole conversation. Actually, in red, you have the packets and the bytes sent by the source, and in blue, you have the receives by the destination. In this case, it's somebody, remember last class, doing a get of a file in HTTP, speaking the protocol, connection closed, the user agent is the Microsoft Network Connection Status Indicator, going to microsoft.com, and the web page says, yes, HTTP 11, 200 OK, that's the answer that everything was correct. The content length is 14 bytes. The date is that one, connection closed, and that are the 14 bytes of the content. That is the content of the file, people. That file you were asking here, this TXT file you were asking in the web, the content is this one here. Okay, everybody? Clear? That was downloading a file from the internet. When you get out with escape, you only see a set of packets. You don't see everything, because if you pay attention, now you have a new filter here automatically when you follow the stream, saying TCP stream 0. So to see all the packets again, you must press on the X here to display the filter, clear the filter. Okay? Everybody? Okay, got you. Now we have more filters. You can search, for example, everything that is DNS. So you go to the filter display and you write DNS, enter. And you have all the DNS packets. See? So you start filtering. This is part of the methodology we are going to be doing. You focus on something, you say, that's okay, that's not an attack, then you put a filter and you get it out. So look at these DNS packets here. We have Microsoft packets answering, Microsoft answering. Then we have, what is the IP address of timetoitout.com? And then we have the answer saying some IP. And then, what is the IP of timetoitout.com? Another one. timetoitout.com, another one. What do you think about this one? Benign, normal, attack, DOS attack, nothing. What do you think? What do you think, internet? Is it trying to find the right port? No, but thank you for the answer. Because its DNS is trying to find the IP address of a domain name, in this case host name. So every time is, I need the address of time2ital.com. And the DNS server says, sure, no problem. The IP address is this one here, 69.65.3200. But why is very fast, because if you go to the right, you will have the time, also I did this incorrectly, I'm sorry. Let me fix this for you. It's gonna be this one. So you should see this, right, in your computers? So if you pay attention, this request was done at something like 1 a.m., 8 minutes, and the next one is 1 a.m., 8 minutes, 48 seconds, and then 54 seconds, and the next 59 seconds, and then 9:05 seconds. It's like very fast. Why somebody would be requesting the same domain one and again and again? Could be a static file that is referencing, could be CDN. If you get out of the filter, so if you clean the filter and you see all the packets, you will see something coming and going in the middle, right? Because it's only DNS. And it's true that some things may happen. The problem is that I don't care what you are downloading, I don't care how many files. The IP address given by the DNS is not going to change for some time. So you don't need to ask every 5 seconds. You actually, a normal computer is caching it for minutes or a day. It's like, I have the IP, I don't need it anymore. That is a suspicious behavior. It's like, why there is a program asking the DNS exactly like very, very fast, right? Like, is it malicious? Probably not malicious now, but it's extremely suspicious. Like, no normal browser or operating system is asking so fast a DNS request, okay? So, you have other filters, so you can play with those. For example, HTTP also is a very nice one, and you will see only the HTTP request. So here you can see what was asking, right? And you can see that some of the things being requested, like post, forum, view topic, are not found, and then you have some that are found. Do you see the most weird HTTP request there? The one that you should say, oh, I think that is actually suspicious. Is downloading an X file. So if you pay attention here, it's trying to download an X file. And actually, it's succeeding. So actually, in this capture, inside, if you are able to get it out, there is an X file. Please do not execute. That is an indication that something weird happened. Like nobody should be downloading without encryption an X file like that anymore, right? So, going back to our visualizations, we also have time visualization. We are going to be a little bit of this one. So, in the menu statistics. That is not good. Statistics. No, sorry, I was mistaken. I was thinking about the display of the packets. No, this is about the column with the time. So, if you want to see this time differently, you go to View, Time Display Format, and the one we like the most are seconds since the previous display packet, View, Time Displayed Format, seconds since previously displayed packets, View, Time Display Format, seconds since previous display packet, and now you will see actually that the requests are done roughly every 5 seconds, see? 5 seconds, 5 seconds, 5 seconds. That is too periodic. Like, no human is clicking exactly every 3, 5, or 10 seconds. That means there is a machine behind that. There is some automation here. Is it malicious? No, of course, bots can be fine. But the fact that it's automation is telling you something about the story behind this capture, okay? So, after this one, there are other things that you can do. In this case, we are going to be adding a new column called host, and this host is going to have this content. So if you copy this content, HTTP host or TLS handshake or DNS query name, we are going to be adding a new column. So right-click as before, column preferences as before. We are going to go to the bottom. We are going to press plus. We are going to be putting as the name of the column host or whatever you want to put. And the type is not going to be number. The type is going to be custom. Okay? As before, custom. And once you do that, now you can put what the previous copy string, you can pass in that field there. Okay? You pass the string that you copy in that field there. We'll give you some seconds.
What's the name of the column?
I put host. You.
I mean, what's the name of the column you are pasting the name in?
Host. Oh, sorry, this one, fields. Sorry. If you see green, that's good. You press enter, and again, you move it up. You press OK, and at the end, you should have a column like this. So this is kind of our special column. So if there is a DNS resolution, you will see here what is being resolved. If there is a HTTP host, you will see there the host. Much easier to see what's going on, okay? Okay with this one? So the only thing I'm going to be saying here is that we are also putting the SNI. So the SNI is a specific field. I'm going to try to explain to you, okay? So focus here. I know it's late and you're tired. I need 20 seconds of your attention. When you are going to a port of a computer, for example, a web page, you go and you say, hi, I would like to encrypt with you because I want to go to a specific web page. Imagine google.com, okay? So you want to go to google.com. So you say, hey, hi, I would like to encrypt. So the computer is saying, hey, that's super good. You can encrypt. But before encrypting, you need to tell me to which website you are going, because computers on the internet share websites. You have one IP, but in there you have google.com, yahoo.com, yandex.com, maybe not those, but you know my point. So many domains and many computers share that IP address. So when you go to an IP address and you say, I want to encrypt, the web server says, awesome, but what do you want? Do you want Yahoo or do you want Google? But you as a client say, no, 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 I want to encrypt. That's why I want to encrypt. I'm not going to tell you where I go without encrypting, right? That's the purpose of encryption. First, let's encrypt, and then I tell you where I'm going. But the server is like, well, if you don't tell me where you're going, I cannot start the encryption. So it's blocked. This is not working. How did we solve it? I mean, the internet. We created SNI. SNI, server name indicator, is a specific field in the TLS encryption header that I'm going to put where I'm going before encryption. So I'm going to say, oh, I would like to go to google.com. And then the server says, oh, super, yeah, okay, so I have here the certificate of google.com. Now I'm sending you the certificate. Now you have the public key. Now we can encrypt, and everything goes fine. But if you pay attention, the SNI went without encryption, which means right now, when you go to a web page that is encrypted with the lock key, everything super green, some information of where you are going goes without encryption through the internet. And the people can read that. Who can read that? Well, somebody that is in your own network, like a coffee shop, your internet service provider, your government, the government of the other country, the provider of the other country. everybody's using this information to know where you are going. And if you thought that because you have TLS, the connection is going to be 100% encrypted, that's wrong. They are not 100% encrypted. I'm sorry to tell you. So be careful there. They know. That is the SNI, okay? So you can analyze a little bit of your scan capture. So remember, we started the capture in the beginning, and it's being stored right now in your TMPs. So in there, you will have a pickup capture that you can see. If for some reason this didn't work for you, you can have our own backup capture that you can find here. So in this place, all of you have a backup capture in case yours didn't work, okay? And you can download this way. So to analyze this capture, you can use the tcpdump as we did before. I'm going to open mine so you see in my Docker how it looks like. So tcpdump -r. See that I'm using -r. That is for reading a file, and it's not -i because it was the interface, okay? So now I'm going to give the file name that is tmp, and then is capture something something 12 something something, okay? And if you do that, and I'm also going to be using the no, that's all I'm going to be using. Pipeless, that's horrible. It's a lot of information. So let me put in here what I'm going to be using. Okay, I'm going to be using this. So this is part of the capture I have from my computer. And you should see something similar in yours, okay? So you should have your file. I have mine. I'm going to be showing some of the commands with this capture so we all of us see the same, but please go into the capture and then see what happened there, okay? If you remember, we started the class sniffing, storing, and then everybody was attacking each other. You were scanning ports, you were doing Nmap, finding port, finding computers, many things happen, okay? So how can you analyze this? Well, with tcpdump or Wireshark, you can analyze this. For example, how many lines, how many packets were sent in the capture? So in the case of tcpdump, you can do this by using pipe, remember? So tcpdump, you're going to find all the packets. Pipe, you are going to show them into a program called WC, word count. It's going to count -L, lines. This one counts lines. So we are taking tcpdump, we are giving it to count lines, and it's going to tell me there are 55,000 packets, for example, in this one, okay? That way you find packets. If you want to see firsthand the content of all the attacks sent to you, similar as we did before, tcpdump, you open the file, you see capital A to see the content, colorize, and less. That is the example of the capture that you should have in your computers of people connecting to you and scanning, see? So we have here, so IGMP query, we have UDP packets, we have the famous echo requests of Nmap, we have some weird packets also here in the middle, we have broadcast packets. I know they are broadcast because all the IPs are in one. It's 255, 255, 255, 255. That's broadcast. Then we have multicast. I know it's multicast because it's like 22400, the network. So many techniques I see in my capture, including all the ARPs. Remember ARPs that Nmap was sending? That is an Nmap scanning in your network, see? And look at this. Who has 172.20.04 says 2. Who has 04? Who has 05? Who has 06? Who has 07? Who has 08? Who has 09? That is finding computers that are up in the network, okay? Do you see that? No? Yes? Somebody lost? Super lost? Internet? Important to know how to find what's going on in your captures. Can you identify the computer that is scanning? Well, if you look at this, in this case, the computer that seems to be scanning is the 172.20.02 because it's a source IP in the majority of the packets. Maybe it's not the only one, but it's the majority here, okay? So that would be the question of who is the scanner. Which techniques are being used? Well, if you look at this, you see ARP ones. But what extra apart from ARP? How would you do that? Well, I will get out, I will go to the filters in tcpdump, and I will put not ARP. Not ARP. Oh, that's too big. Not ARP would mean do not show me ARP. And then we have some UDP ones in broadcast. I will go down. We have more UDPs. We have internet group message protocols. Then we have, remember, the ICMP echo request, echo reply. See? Looking at the packets, one by one, filtering, taking stuff out, you can find all the techniques around it. For example, which IPs were scanned using TCP, and how many packets to each? So in here, I'm going to do a little bit of script foo, a little bit of bash scripting. Follow me in this one, okay? tcpdump, showing numbers, do not resolve DNS, read the PCAP. The source host should be the computer I know is scanning. And packets should have TCP. Then give all of this to the program awk. Do you remember awk we saw last class? Awk. And what you want in awk is to print the 6th column. If you look at the tcpdump, that's going to be the destination IP. And then, because the destination IP is all together with the port, I give everything to awk again to separate by points, because the IP address is separated by points, and only take the first number. That is the IP address, not the port. Let me show you this, so it's less complicated. tcpdump, I'm going to be going up to TCP only, okay? So when I do that, you will see that we have columns 1, 2, 3, 4, 5, 6. If you look at the 6th column, is the IP address, but also the destination port. And I would like to extract the destination IP, not the port. So what I'm doing is giving this string to awk and cutting it with the dots and keeping the first 4 numbers. That is the destination IP. And then I sort all of them. I filter the unique rows. Let me show you when I sort what happens. When I sort, you see all the IPs. When you do unique, you just keep the unique rows. See? Now I only have unique and the number of times each row was appearing. So each destination IP and how many times it appears. And then I just sort again and pipe less. So this is going to give you a list of each destination IP and how many times you saw that IP. Okay? Please check that you can do this, that it works, that you understand what's going on. A small script to extract the information of how many destination IPs and times. Similar to what we did before with Wireshark, okay? And here you have the explanation of the awk. Then we have others, how many unique IPs were scanned, how many subnets and packets are there for each. Playing with these values, you just sort and filter different ones until you find the information you're seeking for. If you have an attack, you want to know how many subnets were attacked, how many IPs were attacked, how many ports were under attack, how many ports were found open, and which IPs. All these questions are questions that you're going to need to understand if you're under attack, and that can be done in this way and with Wireshark, okay? The more diskettes you have, the more complex the question, the more complex the output. So please go through these ones, internet, and try to understand what they are doing, okay? Questions so far? We are beyond questions. I think there are no enough candy to get a new question. Sorry? Yes, yes, we have some chocolates. I think it's not enough, but we have chocolates. So I know it's hard, I know it sounds complicated, but we need you to get into the tcpdump and Wireshark and understand this package. Don't worry, you're going to have the whole semester, but this is an important part of the class. Understanding this with AI is not easy because there are so much data. So AI here has a little bit of a problem. It's not easy actually to go to here, okay? We are going to be doing a last analysis Wireshark. It's not going to be complex, I swear, and then we are going to be stopping for today, okay? So this is going to be just to show you what can you expect in another type of capture, but with Wireshark, okay? Similar to what we just did before, because there are some people out there, they don't like tcpdump for reasons, and they prefer Wireshark. So let's do this last one. If you download from that link the PCAP file that we are going to be using, it's a new one. If you download that one and you open in Wireshark, you will see those packets. That's another capture, also from a port scan. It's a similar one as the one you saw before. All these techniques that you see here are created by Nmap. That's important for you. That is also how a port scan looks like. You will have techniques to find computers with broadcast, techniques to find computers with the discover technique, techniques to find computers with the ARP that we saw. Look at this. I'm scrolling down, scrolling down, scrolling down. Look at all those packets. Can you see the IP address changing here? One after the other, one after the other, one after the other. The similar thing we saw in tcpdump. I'm going to scroll down from here. So you saw more and more and more. Now we see, what technique is that one? Can you recognize the Nmap technique that we did today there? Is the scene scan, right? Look at those scenes. Scene scan, scene scan, scene scan, scene scan. Some computer, in this case, the computer is 172.20.02, sending packets to some computer. Look at the ports, 143, Nmap, 21, FTP, 443, TLS, 3306, what is that? MySQL, 3389, 143, and others. What are these red packets? Can you see? What? Huh? I have a mando for you. I have a mando. The last mandos, like we are gonna recover Mandalorian. We are preparing. We are spread through the galaxy, but we are gonna be doing it. What is the red thingy there? Red is bad, right? Very, very well, Mando! Hoorah! We did it. So that is the answer of a closed port in TCP. I send a SYN, if the port is closed, reset, ACK back. That is how it looks like when all those ports are closed. Scanning again, close. Scanning again, close. Nmap is doing in badges, see? Badges, 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 badges. Port scan, port scan, port scan. Okay? So, small things around this. You can see statistics endpoint, statistics endpoints, and you will find all the computers that were being contacted and how many times. Very easy. If you click on packets, you sort by packet number. Look at this. The computer that received the most amount of packets on the internet is this one with 5,000 packets. Okay? You can also do to which IP and port were the largest number of packets sent, not only the IP, now IP and port. So now you can use conversations TCP, like we did before. Conversations, TCP, and in conversations TCP, look, it's taking time even for loading this capture. And then you can sort by packets. It's taking time. Now I order the sending order. Taking time. There you go. So that source IP connected to this destination IP and port 5400 and send 39 packets. Okay? Is it clear? Do you see what I'm doing? In the assignments today and in the rest and in the exam and in the bonus, there are going to be many things around finding who is the attacker, finding who is attacking more, who is attacking less, what are they attacking. These are the stepping stones for understanding defense, okay? So be sure that you are not overwhelmed. If you have any question, you can ask now, you can ask in Matrix, you can chat us later in any moment. Just be sure you understand this. Practice, touch, go home, open Wireshark, see your own traffic, see something, okay? So, I'm going to show you, the last one is the statistics IO graphs. This is a very nice one. So Wireshark has the opportunity in statistics to show the graph of input-output. So if you click statistics input-output, you will see something like that. That is a graph of packets. Actually, you are looking at this now. This is the graph of packets in time. So if you click time of day, here in the bottom, time of day, you will have exactly the time of day. And you can zoom by scrolling, you can pan out. All those are packets per second. So the more packets per second, the higher the line. So you can see that there was a moment in time that there was more packets sent per second, then not so many, and then more later. You can identify the moment in times where actually the scan was happening. And if you click, if you look behind the screen, when you click, you can actually see and select the packets. So when you click on here, you can then go back and check exactly which packet you were searching for, okay? So I will stop here, not to overwhelm you, and let's close the class. We have assignment.
Yes.
Before assignment, questions, people? Yes? Internet, questions? No? Packets, protocols, port scanning, finding computers, UDP, open ports, tcpdump, Wireshark. Everything clear?
Okay, that means you will do well on the assignment today. So yeah, unlike the last time, it won't be so simple, but it won't be so hard. It's basically a two-parter. The first part is related to the first part of the class, the reconnaissance. You will get an IP range. You will have to find some services there. One service will give you the flag. And there will also be two questions related, not to like the theory of the class, but what you find while scanning for those services. And one thing just to note here, for those questions, in order for us to like stop you brute forcing the answer, there will be like the limited number of attempts you have, but like there's enough if you like actually doing the assignment. It's just to stop you from like brute forcing and trying every possible answer. And yeah, so the two questions and a flag is this like reconnaissance part. The second part is we will basically run tcpdump to capture the traffic for some time, at least an hour. And there you will have to analyze that traffic, and there will flag will be there in some of the packets. You will have to figure it out by analysis. And I mean, that's pretty much it for this. So it's in total 6 points, which is really nice. Yeah, it opens as usual at 9 p.m. tonight, so be ready. Like you can, okay, you can't even try scanning because you don't know the IP range yet, but it won't be like active before 9, even the TCP dump. So you will be able to run everything from 9 onwards. Again, we have pioneer prizes, but for the first person that solves everything, so like both parts, so you might like be the first person to solve like the questions and the first challenge, but then somebody beats you like in all the challenges. So yeah, and again for the 3 places. And yeah, it closes as the previous assignment, October 30th. So like if you're not competing for the Pioneer Prize, you have time, but like it's not indefinite.
Questions? 2-part assignment, port scanning 1, sniffing the 2nd, different points, a lot of points, you need the points. Pioneer, they are saying that the Pioneer prizes for this one are amazing. I don't want to overdo this, but oh my.
They're as nice as the amount of points. Yes.
Repeat.
The question was, do you need to finish the first part in order to do the second part in this assignment? No. So like you can do whichever,
you can do
like,
whatever.
You can run the TCP dump and yes, this is one of the assignments that you can choose to write the report on, and yes, it's for the whole assignment. Yeah.
So if you do a report, this assignment counts, you have time, and then it's both parts for everything, for the reports.
Yes. No, you can, like I will try to, so if you do the report, you have to wait till December to submit it. No, I will like try to create the challenge in CTFD for the report today. So basically whenever you have the report ready, you can just send it there. It's even better for us because it creates less work at one specific point of time for us. So
and please remember internet and you feedback. We really, really need your feedback. It's like 20 seconds. Tell us how the class was. Internet, please tell us so we can improve, okay?
And also for online people, in Strato Cyber Lab, there is a challenge called What is That Noise? That covers these topics that were covered today. So also for you CTU students, you can play this challenge to practice what you just learned.
What is that noise is the challenge in SCL for you, okay? You can go play that one too. Ready? Okay, see you next time, people, and scan all the things. Ooh.